Okay, today we're going to learn about exponential decay. We have an exponential growth and decay model. You recently learned about the growth model, and that was when it was 1 plus r to the t. All right, so this plus or minus doesn't mean that there are two answers. Like when we're taking the even root of something, it just gives both formulas written in one way. And so if it's 1 minus r to the t, then it's going to be decay. All right, let's define our variables here. A is going to be your initial amount. Or what you start with. All right, 1 is always going to be in the formula. R stands for rate. And it's going to be given to you in a percent in the problem. All right, and we must turn it into a decimal. So I'm going to write input as a decimal. It's a very common mistake to miss this part. Oops. So we have to input as a decimal. All right, to input as a decimal, we always divide by 100. All right, so t is going to be time. All right, your percent rate and your time will match units. So you could be decreasing at a percent per year and your time will be years, or it could be percent per month and your time will be in months. The quantity 1 minus r is called the decay factor. And if the factor is between 0 and 1, it is exponential decay. All right, example 1. Is it exponential growth or decay? What we're really looking at here is this value here in this problem, and I'll highlight this one in this one. We're looking at that value there. All right, so this number in front is your A value, and so we don't want to look at that. That's our initial amount. This number here is actually the 1 minus r. So if I look at this right here, 1 minus r has already been put into a fraction for us. So we've already taken 1 minus r, and 7 over 5 is bigger than 1. And so since this, I'll put a little arrow here, is greater than 1, then this is growth. So that's what we mean here. And now you've learned this before. That would be your growth factor. All right. In this problem, we have 2 divided by 5. Now 2 is less than 5, so this number here has to be less than 1. And so this means this number here is less than 1, so we have decay. So it's as easy as that. Example 2. You buy a new car for $24,000. The value Y of the car decreases. So our value is decreasing by 16% per year. All right, so this decreasing tells us it's going to be decay. All right, so we also have some other important information here. We have this value here, which is going to be our initial amount. So I'll put A under that. And then 16% is going to be our R, but remember we have to turn it into a decimal. All right, so the first question says, write an exponential decay model for the value of the car. Use the model to estimate the value after 2 years. So the first thing, and I'm going to label this because there's really 2 things we have to do here. This is the model. All right, Y equals our initial amount, which is A, 24,000. Times 1. That 1 is always in the equation. Because we set up here it's decreasing, this is going to be a minus. That's the difference between your previous lesson. If that was increased, that'd be a plus, which kind of makes sense. We're going to take 16%, which is R, and turn it into a decimal. Just divide in your calculator by 100 if you need to, or you might realize that that's just 0.16. Now, here's where some students get confused on a problem like this. There are really 2 parts to this. Write the exponential model. This model requires us then to put a t here. We're not solving for anything yet. So with your model, you're going to want t here and y here. So this is an equation I would use to answer other questions. This is really done. I'm going to put one more step in here for the model, however, and just take 1 minus 0.16 in your calculator and turn that into 0.84. And then that'll be raised to the t. Let me fix that. All right, now notice I did not plug 2 in for t right now. I'm going to do that in the second part of this question. So that's the model. And so really the second part of this question then is to plug in for t and use 2 years and see what the estimate of the value is after 2 years have expired. All right, and so I'm going to write down here that this is the estimate. And so really 2 separate questions here. You don't want to plug in 2 here yet. You want to leave this as a generic formula or a model that really is used under these circumstances. All right, so y equals 24,000 times 0.84 raised to the second power. And I just run this through my calculator. All right, let me get my calculator out. This is super easy, but just so we all get this right, 24,000. I have an extra 0 there. 24,000. You just type it in exactly as it is. 0.84. And then squared. Now this one we can square it just with the squared key. If this was another number other than 2, you just hit your caret key and raise it to whatever power. And then we hit enter. We get our answer. Now with money we usually round to 2 decimals. And remember, this is your y. And we also put units. Dollar signs are units. So 16934. And then we had 40 cents. So 0.4. I'm going to go ahead and put the 0 on there so it indicates, you know, that we're rounding to 2 decimals or cents. Okay. Now it also should make sense. No pun intended. Okay, maybe I meant to do that. That this number here is less than the 24,000 because the amount of the car decreased. All right, so this is your final answer for part 2. And I'll go ahead and circle it like we often do. All right, part B. Estimate when the car will have a value of $12,000. Now, a lot of times we like to call Y the final amount and A the initial amount. And so in this case, we're actually working backwards for when. And when is always time, so that's t. All right? And this $12,000 is actually not an A. It's going to be your Y value. So let me write this down. We're going to set this up as 12,000. Now, we're still using the same initial value of it, which is 24,000. Times 0.84 to the t. And now we have to solve for t. And unfortunately right now, we don't know how to algebraically solve for t, so we're going to use our calculator. What I'm going to do is put this in y1. This should be a review. I'm going to put all this in y2. And we're going to find their intersection. All right? And when we do that, I'm going to go ahead and sketch a graph of it. And this way you can see what the graph looks like also. So let's get our calculator out. So in y1, I'm going to put, so we'll go to y equals. Make sure your stat plot is off, all right? So I'm going to go to y equals here and put 1,200 in. Actually, 12,000, sorry. And then I'm going to go down here and put 24,000. And I'm going to type this in. Oh, my calculator had a little delay there, so I ended up with too many zeros. Multiply that times, so just as it is in the equation, 0.84. And that's going to be, now this one I have to use the caret key and raise that, and we're going to use x instead of t. All right, what we're really looking for is that t or x. Now here's the tricky part, is our window. All right, now my window's a little messed up here, but that's okay. T is in times and years, so it's obviously we can use x min as 0. All right, and then x max is sort of a guess. All right, I'm going to keep it like we usually have as 10, like 10 years later, and I might have to adjust that. All right, My y min, I'm definitely going to leave as 0 because we're not going to have negative dollars. My y max. Now, what I choose to do with y max is we have two numbers in our equation other than the 0.84. We have 12,000 and 24,000. So to adjust my window, I put my y max bigger than both of those numbers, so 25,000. All right, the window I think is the hardest thing. And then when I graph it, here comes the graph. All right, there's where 12,000 is, and you'll see the decay coming down like that. And it graphs pretty slowly, so I'm going to sketch a graph over here, and this we definitely want you to sketch the graph. Whoops. So when you're solving using your calculator, just give a quick sketch of the graph, and this is good. This is going to be our t, and this is going to be our y. And when I sketch this, it's just rough sketch. That's my line where 12,000 is, and then I'm going to draw the curve coming down, something like that. You don't have to get real detailed. The intersection right here is what we're looking for, and we're actually just interested in the x value, which becomes the t value. So let me get my calculator here. Remember, it's second, trace, and then we're going to go to number 5, which is intersect, so I can hit 5 right away. And all we really have to do is hit enter, enter, enter. And that value for the x is our answer. And so x is about 3.98 years. It doesn't really say what to round to, so I'm going to put 3.98 years. All right, so that's the answer to part B. All right, example 3. Your car is now worth $5,000. You bought it 6 years ago, and you expected it to depreciate 15% each year. How much did you buy the car for originally? Now, depreciate, this is another one of those words that means decrease. And so we are going to use exponential decay again. All right, same formula we used for the last problem. And it looks a little bit of the same too, because we know the final amount is 5,000. However, we're actually solving for the initial amount, what it actually was bought for. So that's my A, times 1 minus. Now, 15%, again, we're going to change it into a decimal, which is 0.15. And we know the time was 6 years ago, so we're going to put that here. Now, the nice thing about this is we can simplify this fairly easy. So 5,000 equals A times 1 minus 0.15. Use your calculator if you need to, but that's 0.85 raised to the 6th power. And since all of this is multiplied together, to solve for A, I simply divide by 0.85 raised to the 6th. And that will give me A. So we'll write A over here. You can do that in your calculator, and you will get, don't forget to put your dollar signs, 13,257.34. And this number here should definitely be larger than the 5,000, because this is what it used to be a long time ago, and the 5,000 what it is now after depreciating at 15% each year. All right, we're done. Have a good day.